So now let me start with this one. Whenever you see square root, we want to remove them. So we'll multiply and divide by something. What's the thing? The idea is use a plus b and a minus b so that you have a squared minus b squared. So we have x squared here, and then the square root is gone. So x squared minus x squared, there's no x squared. So you have a 2x, right? And minus will give you plus. So now I have this. Very likely, you will say that, oh, then I multiply both sides by 1 over x, and then I cancel out term. Yes, but this one is special. So let's see this part. So I have this thing. I take the x out. I get this. And then, well, then square root ab is just square root a square root b, right? So I have this equal sign. I split them out. Now this is important. Very likely, you will make a following careless mistake. This is wrong. It should be absolute value. Okay, why? Well, absolute value is what? Absolute value is plus x minus x larger than 0, smaller than 0, right? So, what's that? Recall, how do we prove two functions are the same? They have the same domain, they map to the same codomain, and then from the left you can go to the right, and or the right go to the left, that's if and only if, right? So, you analyze this case by case. Suppose x is positive, then this part, yeah, we get x. This part, yeah, we get x. Done, easy. But what about if x is negative? If x is negative, this part gives us negative x. This part is what? Okay, if x is negative, that means we have something like this, right? Then you don't see this as a bracket term, you see this as u, okay? Then you have u is negative x, so therefore left equal right. So this saying that what? This guy actually is not x, it's absolute x. So therefore this exclamation mark means that this square root term is absolute value x. This is the first tricky point. The second tricky point is this is absolute value x. And if you look at the limit, what is limit? The limit is go to negative infinity. If x is equal to negative infinity, that means all the x is negative. Negative in absolute value, you need to put a negative sign. So therefore, this thing, you need to put a negative sign. So if you just do this step, what you will get is, you will get 1, this, and then you have a minus. But actually you will get a plus here. This is because you forgot this part. And you forgot this part. So this is the possible case you have careless mistake. So now I have this, easy. Divide everything by 1 over x. I can, again, when you do this, you need to make sure you do not do division by 0. This is okay because I am not doing that before the limit. So this is some number, okay? And then they are both negative. It doesn't matter because the sign cancel out each other. So it doesn't matter. So I put this in, I put this in. This one, the x and x cancel out, so no more. This one cancel the x, get me 1. This one cancel x, gone. So I get this, right? And then I can put the limit inside, it's basically 0. So I have 1 plus 1, 2 divided by 1 plus 1, so it's 1. Now, what if I make the mistake? The mistake I mentioned is that you forgot this part, these two parts. So if I do 1 over x here, 1 over x here, what I will get? I will get a minus sign here. So everything here is the same. This one will become minus sign. Then I will get 2 divided by 1 minus 1, which is 2 divided by 0. That means infinity, which is wrong. How do we know is it true or correct? Well, you can plug in number. So here, let's plug in number. So type this in Wolfman alpha. You know Wolfman alpha, that's lab 1. Then you plot this. I just said from x negative 10 to 10 to the power negative 6. Very big. Then you see this converts to 1. So therefore, this is correct. Forgetting about the sign here is wrong. Any question?
When you've got x nearing infinity, how come once you take the model of x nearing infinity, how is that negative and not positive?
No. Limit means all the x moving towards negative infinity. And everybody here, when they move towards negative infinity, are all negative. And because they are all negative, they fulfill the definition of absolute value that when x is smaller than 0, then I add a negative sign here. Right? You forgot? So absolute value is, if x is smaller than 0, then you put a negative sign. That's absolute value, right? Okay, let me recap. Many tricky things will happen whenever you see things like this, like this, like this, like this, like this, okay, like this, right? For example, this guy is not differentiable, but this guy is differentiable. What about this? What about this? What about this? What about this? Usually, this kind of thing are the tricky part. So the point is, make sure you know this very well, okay? And all the epsilon delta proof also is coming from this guy, right? So basically, this guy is the troublemaker. So let me go back here. So basically, if you plot this is continuous. Okay, let me recap what's continuous. Limit exists, function value exists, and they're equal. 3 sentences. And this is continuous, so this converts to 1. Alright, it will never touch 1 because this is not infinity. So this is how you solve question 40.